Okay, now we are live, and we're going to be starting the countdown in a minute here, in 30 seconds or so. Right. Hello, everyone. Welcome. It is my pleasure to introduce Dr. Lijesh Koottaparambil from Louisiana State University, and he will be sharing knowledge with us on grease condition monitoring of sensors. Thank you very much, and it's all yours.
Thank you very much. So today in LRVS 2022, I'll be discussing about grease condition monitoring sensors. And this presentation, myself, Lijesh, I'm a postdoc researcher at LSU, Louisiana State University. I joined Louisiana State as an Indo-US postdoc fellowship. It is an exchange uh, scholarship between the US. So I work under Professor Konsari, who is a tribologist, and he is a Dow Chemical endowed chair in rotary machinery in Louisiana State University. And along with us, we were Roger Miller, is a chemical engineer, has M Consultancy LLC. He is a retired ExxonMobil engineer. He has 30 years of experience. So he has been the connecting bridge between the research and the industry. So he has a key role to be played in our research. So today's research, I'll be discussing about two sensors. Like we always test on the reliability of the one which is available in the market, but what happens, during the production. So we have a sensor which is during the production for the grease production, monitoring it, and second one is something like a test grade testing which is not available for the grease as of now. So we used a concept called entropy and entropy generation. So this is a very old concept. People think it's very difficult, but this is the simplest concept available. So Clausius, he discovered that for reversible system, that reversible means you start from the same state and end up in the same state. So when you give a heat to the system, the temperature increases. So he defined the ratio of the heat by temperature as change in ds. So he defined the S as entropy. In Greek, tropy means transformation. So this is the basic of entropy. So entropy for a system always increases, is positive, and at equilibrium or at a failure state, it will be 0. So using entropy, there are several researchers who have tried to solve several problems like life of Earth, evolution of biological cells. So the limit is undefined. So now coming to entropy generation. So any degradation process, like any failure system going through failure, is irreversible. So reversible will be doesn't have any damage, but an irreversible system will have a damage. So that damage increases your disorder. So disorder means like your entropy. So those entropy generates is called as entropy generation, and entropy generation is universal mechanism. So we will be using this entropy generation as the topic for evaluating the grease performance. So entropy generation is the amount of entropy which is produced in an irreversible process. So during a reversible process, the entropy generation is 0, but irreversible there is a damage. For example, like wear, friction, everywhere we have an entropy generation. So entropy generation can be the potential mechanism to measure the permanent degradation of any system. So any system which is going through permanent degradation can be evaluated through entropy generation. So the prominent Nobel Prize winners like Clausius, Boltzmann, Gibbs, Onsager, Prigogine, etc. have used the entropy generation to provide to study the complex system like evolution of Earth to biological system. So we have been the present group, we have been like employing this uh, mechanism, entropy generation mechanism, for studying wear, fatigue, and battery. So for example, the wear is the degradation parameter, and entropy flow is measured, it's like a linear. Similarly, entropy generation and crack growth in fatigue is linear. And in batteries, the entropy of battery and the charge, they are found linear. So entropy of a wear is calculated by friction coefficient, applied load, velocity by time. So this is a simple equation. You can see that applying this equation is very simple. So this equation is applicable for an uniform applied load. And so our real system is like non-uniform, it's variable. So this equation becomes with an real-time values. And the important thing is that the famous Archard equation law fails when you apply for the variable load condition. And for example, when you load a system from high to low, will behave from when you system low to high. So those system is characterized by very entropy generation. And finally, if you have a different mechanisms, for example, you have adhesive wear, abrasive wear, any kind of system, you have like different entropy generation. So these can be characterized into different mechanism. Now we are extending this entropy generation concept to the grease. So we know that grease goes through degradation as we work on it. It can be mechanical, it can be oxidation, it can be thermal, it can be contamination. So every state it goes through degradation. So, and these degradation we found that the entropy generation is nothing but shear stress into shear rate divided by the temperature. So this one is linearly proportional. So we finally say that using entropy generation, we can characterize the grease degradation happening with time. So the real-time measurement for an example in an application, if you want to measure the shear stress and shear rate, we use to have a torque sensor. Even the primitive like the rheometer also have a torque sensor. So we use torque sensor to measure the shear entropy generation. But the problem is that installing a torque sensor, you have to cut the shaft between the motor and the working medium, so which is not possible in an existing system. So for that, we came up with an indirect way. So by measuring entropy generation and power, since power and entropy generation are correlated, because a motor torque can be connected to the voltage and current. As you load the more the motor, the current is going to increase, same as a torque. So this is an indirect way of measuring the entropy generation or the torque. So we use voltage and current of the motor to measure the power, and we correlate the entropy generation. So now, after developing the concept, we developed an instrument in our lab which to measure the current of a motor. So we have a motor, we have a current sensor, and then we have a DAC. Then we used Arduino board to measure the online value, real-time current value. Based on that, we tried to measure the entropy generation. So to implement the concept, we had a viscometer, we modified the viscometer, and we connected the power of the viscometer to the developed prototype, and the sensor will give you the signal to the laptop or mobile phone. So this is the result we got it from the sensor. So initial current region 1 is the one ideal condition. So region 2 is initial non-uniform, because you can see on the left and bottom side, when we apply the grease, it's non-uniform, random, and as you go with the time, it becomes a steady state, a uniform mixture, which can be seen in the second picture. So that's the region 4. So the entropy generation is nothing but voltage into the prevailing current minus initial current. So the region 1 has some initial current, we have to subtract it. That's the entropy generated to damage the grease. So that's the point, like we have to find how much is entropy generation has been put onto the grease to damage it. So when you subtract the initial current, the final current by the initial current will give you the change in current into the voltage remains constant and the prevailing temperature. So GCMS, that is grease condition monitoring sensor, characterizes grease behavior inside the system. And we presented this topic in NLGI mid 2019. And that's where we came to contact one person and from a company, and he wanted to test this sensor for his for the grease kettles. So now we shift this topic to the grease kettle monitoring sensor, adapt this grease entropy generation for monitoring the what's happening in the grease kettle. So grease kettles are used for manufacturing grease at different type of grades. To know the consistency of the grease, sample are collected by interrupting the grease kettle. So after the grease manufacturing is done, they collect the sample, they cool it in a freezer, they work it for 60 stroke, and then they have to come to 25 degrees centigrade. Then they do the consistency test. So they have to do this test. If the consistency is higher, they will add the oil to the grease sample, and then they will mix it. So this will go on until the you reach the desired grade. But if it is the lower level, if the penetration is higher, the grease has to be discarded. So you need to have a grease some monitoring sensor to see that what's happening inside. So the wrong measurement of penetration may result in discarding the batch. And one more thing is that the QC check limitation. So the QC check doesn't happen immediately. So then presently the testing is done by the process engineer who takes the sample, he does immediately and decides the checking. So for QC check, for example, if some grade of grease is going on, so they will wait for other grade of grease or the other type of grease until that process is finished. So the waiting limit wait time is there for a test to be happen in QC. The quality check has to be done in the lab. So this takes time. So there should be a medium where the process engineer who tests the sample and some sensor which says that no, you are on the right time, it will help giving the confidence. So for the initial stage, the kettle manufacturer send us the lab size kettle for testing the our prototype which we developed at LSU. So he loaned us the 5-gallon capacity grease kettle manufacturing process, and we connected the current sensor to it, to the control panel, and we used a Raspberry Pi and Python to program it and to evaluate the system behavior. So we were able to get, since we at LSU we are not able to manufacture the grease because of the hood problem and higher temperature, smoke release. So we tried with the existing manufactured grease. So as the temperature was increasing, the consistency of the grease reduced, which is monitored through the agitator current. So we connected the current to the agitator motor, and the motor current was reducing, and as the temperature was increasing, reducing, and the consistency was increasing. So this is something like, we can say that the consistency is increasing or reducing just by monitoring the current value. And also we found that the penetration and the agitator current had a linear value. So this penetration is done by ASTM standard using a penetrometer. So those value and the agitator current value are approximately the same or linearly proportional. So now we did the 5-gallon test. So we had to test it for an industrial application. So for that, we did a field testing on a 15,000 gallon grease kettle. You can see on the left hand side, this is a grease kettle, and we didn't interrupt any of the system. We hang the current sensor, split type current sensor, into their control panel, and we monitored the how is the current is behaving. So this is the process which is involved inside the grease kettle. Like we add oil, they add acids, they heat it to 200 Fahrenheit, they had a collate, then they heat it to 400 Fahrenheit, cool it, then mill it, additive, etc., etc. So they have different uh, process involved during a manufacturing of a grease. So I have separated into 7 different regions. So acid plus base, collate, heating to 700 degree, 400 Fahrenheit, 300 Fahrenheit, etc., etc. So on the right hand side, you can see the current we have measured using the current sensors, which was implemented on their control panel. So it is able to characterize what's happening in the system. Like the current value is reducing. This here was reducing because the alcohol was evolving, and until the 400 was reached, it reached the maximum temperature, maximum current, and then it starts to reduce. And this, during the process 5 mill current, during milling the consistency is increasing as well as temperature is dropping, so the current value was increasing. So using this, we were able to say that what's going on the inside the kettle. So for example, like here is the maximum region, but the 400 they have reached was away from it, so the reaction has reached the maximum point and it has dropped. So everything can be monitored, can be seen outside the kettle using the current value. So how is the entropy value is helpful? So what we do is that we calculate the entropy using like voltage, current, and temperature value until the process is finished. So this is the so on the left hand side figure is the penetration value measured by the practitioner, the QC check lab, and in that you can see that batch 1976, 1983 are on the lower penetration. That means the grade is higher than grade 2. And similarly, when you see that in the process chart we developed for the entropy generation, you can see that the the batch 1983 and 1976, the entropy generation is higher than the limit. So this is something like saying that, this gives confidence for the person who's doing the penetration on the spot, rather than QC check, like your value is higher, so he does a double check, and he can add the oil now, so that he can get it to the right consistency. And in other case, if it goes to the lower grade, so our sensor will give a warning signal that you are going towards a lower limit, you have to stop the operation, or you have to take corrective action. So this sensor will give an information to the user through mobile phone or through your system that something is going on, take the corrective action. So what we found is that during these two batches, they added the coal hit very fast, so that the reaction happened faster and it ended up in higher grade grease. So these things were able to find it out using the entropy generation value. So from the conclusion of entropy generation, so GCMS helps in understanding the process happening inside the kettle. So it's a commercial scale process. Amperage and temperature data can be used to calculate the entropy, and based on that, you can correlate the penetration value. So earlier process warning provides limit to batch investigation and process adjustment, which will minimize process rejection. So this is the advantage of entropy generation. So next, I'm going to talk about my second sensor we developed at LSU. So this is like a contact angle setup. So we tried to develop an portable contact angle instrument. So the existing the standards available, what it says that uh, it says that how it is adheres to the, like for example spray off test, it says that how well the grease is attached to the bearing, but doesn't say that it is water repellent or water absorbent. And these tests has to be done like drying water, they had to like 77 degrees centigrade, so that some of the lubricant like grease property gets evaporated during that course, and not capable of assessing water repellent or absorb, and require large quantity of grease. And another thing is that when penetration test was done on different greases at different location to establish the ASTM standard, several places they had a positive penetration change. That is, when you add a grease, when add a water to the grease, the penetration value, like the consistency increased, and some place consistency decreased. You can see that for two different greases, the consistency has increased in the things they have become thick, and in other case it become thin, like it becomes fluid. So like when you put a this kind of, when you measure tried consistency change in a grease sample, addition of water, it's can't put in a single platform, because one is positive and other is negative. So then we came up with an contact angle method. So this is like when we were working on coating, and then on the coating, like we had to evaluate the coating performance by measuring water droplet onto the surface. So based on that, we developed the contact angle performance method. So this depends on not the physical, based on the chemical uh, measurement. So initially we started with the cruise contact angle measurement system, but it's not a it's not portable. So we had to have a like portable, like we had to go through three different stages. So last one is the final stage. So we have a grease holder, we have a pump. So the pump is like for the uniform measurement of the water droplet. So you can see that this is the final output. So we developed a GUI in the lab. So everything was done at LSU. So this is how the process done. So you put a grease sample, and then we have a GUI. we start recording and then water droplet comes in. You can see the water droplet on the grease surface, and then you have to wait for like 60 seconds, and then you wait for a few minutes, and the results comes in. So a grease having a good grease, like a good water resistant property, will have a higher contact angle, while a degraded grease will have a lower contact angle. And this is how we prepare the sample. We have developed a grease holder in our lab, particularly for the grease, because the grease being a semi-solid, and unlike like solid coating and all, so we had to come up with this grease holder. So we fill the grease in a slot, and then we wipe the grease off, and then we move the grease holder downwards so that you can see the projection of the grease. So this grease comes in for the testing. So we use this grease for the testing. And we did evaluate the sensor working at one of the company, like they have agreed to prototype and sell in the market. So they have purchased the prototype and say they will commercialize it. So we have tested the samples in their premises. They developed 3D prototype the machine, and we developed it. So, and they tested in their lab, and we tested. So the maximum difference in the contact angle we observed is like 1 to 2 degree, the contact angle difference. So it seems to be repeatable, as well as it is like a very robust testing machine. And then we applied for different testing. For example, like we got the person Roger got 4 different samples from paper mill industry. Like we had a new one, we had 8 weeks, then a front side and back side, so which was run like several hours of testing. You can see that they have oxidized. And when I used the rheometer testing on the tables, they were not showing any difference. But when you use a contact angle, they were showing difference. Like for the new, it is contact angle is high, and the front end side it is lower. So it can say that the grease on the front end side has degraded. So this decision can be made by the practitioner by taking the prototype to the industry directly there, rather than he goes to the QC lab check and the industry has to wait for it. And second one is that the consistency of the grease also formed linear, because as you add the oil, the water property will change. So thickener is more, oil is less, the water droplet will be higher. And similarly, the more the oil, the water droplet will go down. So this can also be implemented for measuring the consistency. And third one, this is like an grease. A fellow mate got it from a bearing which was running at 10 years from a naval plant. So they had a grease sample. You can see that it has 2 colors. One is like whitish and a brownish. So when I use both mixed one, I get a contact angle 74. Then I try to segregate those white one and segregate the brown one. So when I segregate it, the contact angle seems to be different. For example, the whitish one seems to have contained more water in it, and it showed like a lower contact angle, while a darker one showed higher contact angle. So in the conclusions, so this can assess the degradation of grease. So contact angle approach. So our objective was to make it as a portable unit, and the procedure is simple, doesn't need an expertise. You need to only preparation of sample by wiping off the grease. The result can be generated in 1 minute, and the customer can plan their maintenance. So the advantage is that it's a portable. You can take it to any plant and do it, because it involves Raspberry Pi, which can be operated in power bank, and it requires only 100 grams of grease is required for testing. Like the present test methods, they can't test a small grease bearing. However, using this approach, we are able to test the grease samples from a small grease bearings, as well as you can take samples from different slots and test it. Thank you. That's it. Thanks for the patience.
Good. We have just time for one question. I'm showing it right now. Is it also useful to measure non-mechanical properties in grease, like quality of the lubricant used in the grease? This is from Carsten.
Yes, it is. So you can see that this was developed for water actually. Because you have more water in the grease, the water you drop a water droplet on it, it's gonna show the lower contact angle. Then we realized this can be used for mechanical, then it can be used for an oxidized sample. So this is also applicable for entropy generation method also, where like as I said, like entropy generation has classified different entropy. One is due to oxidation, one due to mechanical, one due to thermal. So that's what the entropy generation is strength is. We generally, even in the where, what we do is that we take a cumulative degradation, but it's wrong approach, because every degradation happens its own way. So we have to separate it, and this separation will lead you to different uh, understanding. For example, a grease, when you rotate it like a higher temperature, it will go degrade through the temperature. It will degrade by the mechanical shearing, and it will degrade by both the mechanism. So that's how the entropy generation method is adaptable, helpful.
Lijesh, we have time maybe for just one quick question. Do you recommend any specific brand reference for the portable device?
So this is actually, we have a patented technology, because the existing portable device are not used for the grease, because they have the others for the coating. So you have a solid surface, so you have to just drop a water droplet on it. But for the grease is a semi-solid, so you can't spread it and put it, because it will have a non-uniform results. So one industry has purchased our patent, and we have tested their premises. So by this year end, they will release the product. That's what the legal terms between LSU and the company has been made, and they should release the product by this year end in the market. So probably this.
I recommend, because we're running out of time, I would recommend Juan to send an email directly to Lijesh, and he can follow up with you and give you some further information. That could be useful. But so we reached the end of our presentation. Thank you very much, Lijesh, for this very interesting presentation. And I hope you enjoy the rest of your lectures that you may be attending. Thank you so much.
Thank you.
Thanks, everyone. Thank you.